Now we're going to take a look a little bit more specifically at using 0 as an exponent, as well as introducing what negative exponents are. Once again, let's start with the pattern over here on the left. We're starting with our positive exponents, and I'm starting with the number 100. 100 is the same thing as 10 squared, 10 to the second power. Let's go to our next number, 10. Well, 10 is 10 times less than 100, which means that the exponent representing it needs to be 1 less. 10 is the same thing as 10 to the first. 2 minus 1 is 1. 1 is now 10 times less than 10. 10 divided by 10 is 1. So if this is 10 times less than this 10, then the exponent here needs to be 1 less than the exponent for this one. Well, the exponent for this one is 1, therefore 1 less than that would be 0. So we can see that 10 to the 0 power equals 1. Well, now 0.1. Well, that can also be written as 1/10. 1/10 is 10 times less than 1. So based upon this pattern, what do you think the exponent would be? Well, you keep the same base, 10, and you need to subtract 1 from the exponent here. 0 minus 1 is a minus 1. Then lastly, we'll take a look at one more here, 0.01. Well, that can also be written as 1/100th, or 1 over 100. 0.01, or 1/100th, is 10 times less than 1/10, or 0.1. So if it's 10 times less, we need to keep the same base, 10, and we need to have an exponent that's 1 less than this one. Minus 1 minus a 1 is a minus 2. So we can see here that not only do positive exponents go on forever, but we also can see that negative exponents can go on forever, because we can continue to add more decimal places to the right of the decimal point here. We can see then that negative exponents are used to write or represent numbers that are less than 1. Rewriting this then as a statement, x to the minus a power is going to be the same thing as 1 over x to the a power. Now, what do we mean by that? Well, let's take a look at some examples here. We have 1 over 3 squared. Well, what is 3 squared? Well, 3 squared is 9. So what we have really going on here is 1 over 9. Or if we want to rewrite that with exponents, it would be 1 over 3 squared, which is what we started with here. But what we're really after is, what do we originally start with as far as an exponent? What is it that equals 1 over 3 squared? Well, what it is 3 to the minus 2. 3 to the minus 2 is the same thing as 1 over 3 squared. So here we started off with the answer in the 1 over x to the a, and we needed to work backwards and found that our answer is really 3 to the minus 2. And if we were to start off with 3 to the minus 2, we would see that 3 to the minus 2 is the same thing as 1 over 3 to the positive 2, which is then the same thing as 1/9. 65 to the minus third. So we started off with this component of it. Rewrite that now as a fraction. Well, as a fraction, that would be 1 over 65 to the positive third. Now, let's calculate out some answers. 19 to the second divided by 19 to the fifth. Do we have the same base in the top and the bottom? Yeah, the base is 19 for both of them. So our answer will also have a base of 19. Then, since we're dividing by the same base, we subtract exponents. 2 minus 5 would be a minus 3. 19 to the second divided by 19 to the fifth equals 19 to the minus 3. Lastly here, 2 to the third divided by 2 to the third. We have the same base in the top and bottom, so that means our answer will also have the same base, 2. Then we subtract exponents. 3 minus 3 is 0. 2 to the third divided by 2 to the third equals 2 to the 0. And as a quick reminder, what is any number divided by itself always going to equal? Well, it's always going to equal 1. 2 to the 0, therefore, must also equal 1. Lastly then, as far as a review, any number that's raised to the 0 power is 1, and that's expressed by x to the 0 power equals 1. And lastly, a number that is raised to a negative power can be indicated by the following. X to the minus a is the same thing as 1 divided by x to the a. That then will wrap up session 53.